Linux in DevOps. Linux is an open-source operating system that powers servers, desktops, mobile devices, and even cloud infrastructure around the world. In today's session, we'll explore one of the most powerful foundations of Linux. Introduction. History of Linux. Why Linux? Why is Linux so secure? Linux vs Windows. Why does Linux dominate the corporate side? Introduction. Linux is an open-source operating system, OS, that acts as a bridge between computer hardware and the applications you use. It manages hardware resources like the CPU, memory, and storage, and allows multiple programs to run efficiently at the same time. Key features of Linux. 1. Open source. 2. Secure. 3. Stable and reliable. 4. Multi-user and multitasking. 5. Highly customizable. History of Linux. Linux began in 1991 as Linus Torvalds' personal project, evolving from a simple kernel into a global open-source powerhouse. By 1999, it had gained traction in servers and enterprise systems. In 2010, Linux dominated cloud infrastructure and mobile via Android. Today, in 2023, it's the backbone of DevOps, AI, and edge computing, leaner, faster, and everywhere. The power of Linux, revolutionizing modern computing. Operating system. Democratized operating systems through open-source collaboration, breaking the monopoly of proprietary platforms. Enterprise servers. Became the backbone of enterprise servers, powering web hosting, databases, and mission-critical infrastructure. Cloud computing. Dominated cloud computing and mobile ecosystems, Android, AWS, Azure, and Kubernetes all run on Linux. Security and stability. Proven itself as a secure, resilient OS trusted by governments, banks, and global tech giants. DevOps and automation. Enabled modern DevOps workflows with tools like Docker, Ansible, and CI/CD pipelines, all thriving on Linux. Why Linux? Linux is secure, developer-friendly, and packed with powerful built-in tools. It supports easy updates, automation, and customization, making it ideal for modern DevOps environments. Its strong performance and clear error messages help ensure smooth system management. The market growth, from $6.48 billion in 2023 to $15.63 billion by 2028, shows Linux's rising global demand and trust in the tech industry. Linux is highly secure and protects systems from viruses, malware, and worms. It uses secure user privileges, giving limited access to reduce risks. Being open source, it allows full transparency and customization. Its efficient memory management keeps systems fast and stable, while log records help track activities and troubleshoot issues easily. That's why Linux is the primary operating system preferred by professional developers around the world. Linux versus Windows. This comparison highlights how Linux and Windows differ in performance and usability. Linux is lightweight, requires less storage, and offers greater security with open-source flexibility. It's ideal for developers who prefer control and customization. On the other hand, Windows provides a user-friendly interface and wide application support but consumes more resources and offers less security control. In DevOps, Linux is often the preferred choice because it's faster, secure, and cost-effective for managing servers and automation. Linux dominates the corporate world because it's open source, highly stable and reliable, offers great scalability and flexibility, and provides strong hardware support. Along with its enhanced security, these features make it the top choice for businesses. Linux distributions. General purpose and beginners. Ubuntu. User-friendly, great community support, suitable for beginners and professionals. Ideal for desktops, servers, and cloud applications. Linux Mint. Based on Ubuntu, Debian, it is designed for ease of use with a familiar Windows-like interface. Excellent for users transitioning from Windows. Zorin OS. Tailored for beginners with a polished and intuitive interface. Specifically designed to mimic Windows or macOS. Power users and developers. Arch Linux. Lightweight, flexible, and minimalist, users can customize every aspect. Best suited for advanced users comfortable with command-line configurations. Fedora. Cutting-edge technologies and frequent updates, supported by Red Hat. Favored by developers for its focus on innovation. Servers and enterprises. CentOS Stream, Alma Linux, RHEL. CentOS Stream is a rolling preview of RHEL, while Alma Linux and Rocky Linux are community-driven RHEL clones. Used extensively in enterprise and server environments. Debian. Stable and reliable, with a vast repository of packages. Popular for servers and large-scale applications. Security and privacy. Kali Linux. Specifically designed for penetration testing and ethical hacking. Includes a wide array of security and forensic tools. Tails. Focuses on privacy and anonymity. Routes all internet traffic through the Tor network. Linux file systems. ext2. Use case. Suitable for flash drives and SD cards. Features. Simple, lacks journaling which makes it less robust against crashes. ext3. Use case. General-purpose Linux file system. Features. Adds journaling to ext2, improving reliability and recovery. ext4. Use case. Default file system for many Linux distributions. Features. Extends ext3, adding larger file system support, better performance, and more efficient disk usage. JFS. Use case. IBM's high-performance journaling file system. Features. Efficient for large file systems with low CPU usage and fast recovery. Ricer FS. Use case. Advanced file system for Linux. Features. High performance, efficient with small files, and features journaling. XFS. Use case. High-performance computing environments. Features. Scalable, high-speed, supports large files and volumes. BTRFs, B-tree file system. Use case. Modern, feature-rich Linux file system. Features. Snapshots, pooling, checksums, and integrated multi-device spanning. Linux directory structure. The Linux directory structure is organized in a hierarchical tree starting from the root directory. Key directories include bin, essential binaries, etc., configuration files, home, user data, var, logs and variable files, and USR, user-installed applications. Each directory serves a specific purpose, ensuring a standardized organization for system files and user data. Commands. A command in Linux, or any command line interface, is an instruction given to the system to perform a specific task or operation. It can be internal commands or built-in commands. These are built into the shell, e.g., cd, echo, pwd. They are executed directly by the shell without requiring an external program. External commands are executable commands. These are separate executable files stored in directories like bin or usr, bin, e.g., ls, grep, ping. The shell locates and runs these commands via the system's path variable. Commands often include options to modify behavior and arguments, inputs for the command. For example, lsl, home. Here, ls is the command, l is the option, and home is the argument. Some basic commands: ls lists the contents of a directory. cd changes the current directory. pwd displays the current working directory. mkdir creates a new directory. removes files or directories. All the examples are available. cp copies files or directories. mv moves or renames files, directories. Touch creates an empty file or updates a file's timestamp. Cat displays the contents of a file. Echo prints text to the terminal or writes to a file. Top displays running processes and system performance in real-time. Chmod changes file or directory permissions. Chown changes file ownership. All the examples are available. df displays disk space usage. do shows directory, file size. ps lists current processes. All the examples are available. System information. Date, show current date, time uptime. Show uptime WOMI, who you're logged in as w. Display who is online. Cat, proc, CPU info, display CPU info. Cat, proc, meminfo, memory info. Free, show memory and swap usage. Do, show directory space usage. Dushish, displays readable sizes in GB. df, show disk usage. Unama, show kernel config. Networking. Ping host. Ping host hoist domain. Get hoist for domain dig domain. Get DNS for domain dig x host. Reverse lookup host wget file. Download file wget c file. Continue stop download wget rurl. Recursively download files from url curl url. Outputs the web page from url curl o meh. HTML URL. Writes the page to meh. HTML SSH user at host. Connect to host as user SSHP port user at host. Connect using port. Processes. PS. Display currently active processes. PSOX. Detailed outputs. Kill PID. Kill process with process ID. PID. Kill proc. Kill all processes named proc. Permissions. Chmod octal file, change permissions of file. 4 read. R, 2 write. W, 1 execute. X, order. Owner, group, world chmod 777 RWX for everyone chmod 755 RW for owner, RX for group world. Some others use full commands. grep pattern files. Search in files for pattern grep r pattern dir. Search for pattern recursively in dir locate file. Find all instances of file where is app. Show possible locations of appman command. Show manual page for command. Thank you for your attention. This is just a beginning. More to explore in the next part.